Okay, good afternoon, everyone. It is my privilege to hold this talk on electronics as a part of Career Week 2026 held by BITS Embryo. And let's begin. It is my privilege to welcome our esteemed speakers for today's session. Let's start with Sukriti Kumar. Yeah, so she is a digital design engineer at Intel, contributing to advanced semiconductor and digital hardware design with experience in core system level development. And on the other side, we have Ankit Kumar. He's a VLSI engineer at Intel, bringing practical expertise in the semiconductor design and a strong understanding of the technical and professional competencies required in the core electronics industry. And he also has a reputation for helping students through this semiconductor journey. We are honored to have you both with us today to share your insights and experiences. Today's discussion centers on understanding the evolving landscape of electronics and semiconductor industry, the challenges, the opportunities, required skills, and the new technologies like AI that have been changing the course of electronics. All right, so I'll start with a few questions. So, my first question to both of you is what was the biggest challenge you faced during your journey into core electronics industry and how did you both overcome them?
Okay, hi everyone, I'm Supriti. And the question you asked. So, for me, I think it's like what we study in our courses, what we study in college, and what we have to apply in industry, it is a gap. So, even though we learn the same things, we learn the same technologies, but the way we apply it in domain in the industry, it is quite different. So, there are a lot of tools you need to be well versed with, and that's where internships help because they give you some experience, they give you some knowledge about it. So my internship was also in Intel. So like we studied STA, we studied ADVD, we studied basics of everything, but the way we apply
Mhm.
it in systems, the tools we use, that's quite different, and there that's where internship bridges the gap between the working and your uh, basic knowledge from college. So that's for me.
The biggest challenge. Okay.
Yeah, so maybe I will add my points and thanks for introducing. So, for me, biggest challenge or for anyone will be on two fronts. One will be, of course, work. Okay, so it's like a change from exam-based study to a real engineering problem-based study. It needs certain bit of fundamentals. Okay, and it makes you believe that okay, adding fancy things is one thing, but why everyone or every company always focuses on fundamentals? Because when you come to industry, then you will see that it is the fundamentals that are taken care, and people are way smarter to build on top of it. Every time you have to check something fundamental. This is one. Second will be anyone entering the industry, a challenge will be on the personal front. Uh, you will be changing your place, right, from a place to directly going to the corporate. That is another skill in which if you are getting an internship, it's good that even before completing your course, you get a feel of the corporate. So there are two sides you have to balance: personal and of course the work.
All right. So how did you two manage to balance the personal and like the transition from the theory to the application?
I think
So
yeah, so that's where internships help, your mentors help. Starting like your first 3 4 years of career should be more focused on learning, and learning can be in any field. You can do your own research, you can do your own research, you can read research papers, or you can learn the tools and like gain experience doing hands-on work. So it can be in various things.
Okay,
seniors
okay.
seniors will help actually.
Yeah,
So
yeah.
if you are
Seniors.
only learning with your experience, life is too short for it. So you
Yes.
have to learn from others' mistakes. And for that, more community you will build as soon as you enter. It's okay later on in your career you can cut it short, but initially try to talk to more and more people. That's what internship is, the early breakthrough. Like, you are still a student but you still have all the resources. So if
Yeah.
you have an internship, you are very lucky, and you should use it like that, because you are not an owner yet, but you can use all the resources that another other people use. Plus, people will treat you is like it's okay that you are still a student. You can go and
Yes,
ask any
yes, yeah.
blunt question to anyone. So that's how we should use the early phase of the career.
And even though it sounds difficult, but you need to be actively interacting with a lot of people. Anywhere you are stuck, you have to interact with many people. Even though some, like initially it is difficult to make friends, it is difficult to approach new people, but that's what helps. That's what helps later.
All right, that sounds perfect. Now, let's move on to the industry that is changing right now. So, let's talk about the evolution. How is the electronics industry, engineering roles today have changed from the past, and what should students do to be relevant and stay up to date with it?
So industry is ever changing, and again, the tools remain the same, the basic processes are same. Now it is just more technology is being incorporated, like again AI and like scripting you have said. So yeah, that is happening because like much of scripting is now happening via some AI tool. You do not need to write every code, every line of it. So that does help, but your basics should be clear. You still need to tell the AI tool what you want to do, what script you actually want. So it is based on both. So I really believe in, you should be clear with your fundamentals and you should be clear with your basics and the actual working of the systems, and AI can help you in that.
Yeah,
Okay.
in almost on the similar
Um,
lines. This field is not only maths or only based on certain past data. In semiconductors, the main thing is physics is involved.
Yeah.
There you will have an advantage. So that's why fundamentals. It's
hmm.
not something that it's machine learning is okay, but it can be done only up to a certain extent. Like, as even in chip design, right? As we go to the next node, no one knows. From the past nodes, we don't know the issues of the next node, like
Hmm.
40 nanometer. Then you'll go to something. Now we are 7, 5, 3 nanometer. 5 nanometer concepts will not apply to the 3 nanometer. I mean, basics will apply, but the new things which will come up has to be dealt with the engineer, because your devices has shrinked. You have made it more complex. So you need to know the basic device to play with this device. You can't feed that easily to a machine learning code.
Oh, okay. So, would you say that AI ML is not threatening the real high level and innovating jobs that are present in today's market?
uh, I don't think that's true for hardware because again, like jobs are there. You basically what students should do is like you should be clear with your basics. You should be clear with your hardware core knowledge. You should know your ADVD concepts, STA timings, and you should learn a little bit of AI. That way, it aids you. It aids you in your engineering problems. There are whole teams which are just AI teams, and if we go and tell them our whole of the problems and list them, there it is still difficult for them to understand. It is still difficult for them to apply it. But someone who is in between, who knows the core and who knows some bit of AI, can easily do that task, which a whole team was not able to maybe easily do for us. So it is not threatening. And again, machine learning that can be used. So we have large amounts of data, we have huge data. So like my team does analysis based on timing and power of every node, every path. So like there are multiple paths, there are lakhs of paths, then there are paths, and then there are timings of everything. Now we have to converge the design. So we have all this data. We might think, okay, we might change this and then go back and run this and then see what happens. So this run process is the placement process, or the running of the placement process. Itself it takes like 3 to 5 days. So if machine learning can predict, okay, this change will help you in timing by this percent, that helps us, that saves our runtime. So it is helping us rather than removing our job, because still it is giving us some idea which which as engineers we have to think and critically analyze if it is working or not. And based on that, we either include it or do not include it. And like somehow integrating ML and AI into the processes is the next thing which is happening. For me, at least, I think that is the case.
Yeah.
Okay. Ankit, would you like to add to that?
Uh, Same, almost same. That it will take away the redundant jobs,
Yeah.
more so in the coding field. But this field, as I told, so we have to understand what is the basic, the base of engineering coding jobs. For example, I compare always VLSI with coding. The base of coding job is maths and algorithm. Algorithm
Hmm.
is something you can predict. Uh, and again, maths is something you can teach a tool. Doesn't mean all the coding jobs will be gone, but any repetitive job, right, it will be gone. Now here, along with this maths algorithm, physics come into play.
Yeah.
Now, physics is a very tricky thing to teach a tool. That to physics of a technology which is not yet discovered. And we, for VLSI, we are moving there. We are going to 3 nanometer, 1 nanometer. No one has even seen that. We are going from MOSFET. We started with the JFET and BJT, now FinFET. We are moving to even further technologies nobody knows. So here, teaching it again, it will take the redundant job, and you can't sit there that my job will not be taken. But if you integrate your job with a bit of AI, then you are irreplaceable. At least for the near future. Again, we are none of us are experts, but that level of expert, because that is being decided by the CEOs and all, right? What it will be done in the next future, but it doesn't look like it's a more likely safe field for the next few years.
And also with, so this is something I think you guys can relate. So Navneet sir is our HOD right now in electronics, right? So he once told me this. He said that in IT jobs, in you are replaceable, but in EP jobs, no one is actually replaceable, because the more you gain experience, the more of an asset you become.
Hmm.
So with experience also it adds to that. So in IT, experience is not that much relevant as in ET.
All right. That's amazing. So you said that the coding jobs will take a hit when it comes to AI. So how would you say that which language should the students learn to better help them in their journey in AI, in ET, sorry.
Uh, okay, maybe
Like
I'll.
which coding language? Like Verilog, System Verilog, Python.
Okay, so again, maybe it's little philosophical, but whenever some storm comes, right, then you have to find the safest place. Just like now, economic market is down, right? So everybody is going to gold. That's right. When
Yes.
a big change happens, we have to stick to the basics.
Hmm.
Basics is Verilog, but Verilog is nothing. Okay, it's a normal code. It is digital electronics.
Yeah.
Digital electronics written in a if-else coding form.
Mm-hmm.
You don't learn if-else also. Anything which your tool gives is sort of redundant. You can write on ChatGPT, right? Verilog code.
Yeah.
But if someone gives you a circuit and a Verilog code and tells you, does this circuit behave like this Verilog code? That's where intelligence happens. That's where I can show you that ChatGPT will do mistakes.
Yeah.
Okay,
Hmm.
can give you a wrong circuit. It's not trained that much.
At
Okay.
least right
Okay.
now.
Yeah.
But
So
So
we need to.
yeah, basics is only single language which is very low. Uh, you can mix it, but leave these languages, go towards even core things like digital electronics and algorithms. Algorithm side, you can learn something like a Tickle, Perl, CSH, C language. But or you can even in interviews they're okay if you tell that I'll write a dry code. I don't know if else, but for it will this loop will run 10 times. You can tell like that. Everybody knows you can search a for loop example and you can write it. But your real case, let's say you have a case and there you have to write a code. That are you able to do or not? So we have to stick to the basics.
Yeah, Verilog, Tickle, basics of Python is also required. It helps in all kinds of job. But again, that is for understanding. Like you should know the basics and you should be able to read the code. If some AI tool is giving you a code, you should be able to read it and like analyze it if it is working or not. So basics of coding for at least not like IT coding, basics of Python coding.
All right. That's actually a little bit relieving, I believe, for the students to hear
Yeah.
that they don't have to. Yeah. So my next question would be, how are the critical core courses like? How are they like? What are the critical core places where you can go in ET? Because there's a lot of branches. Even you two are from different parts of ET. So how do
So
you choose as a student?
again, it is you can shift between branches, like you can shift between domains even in your like first 3 4 5 years, or maybe with experience also. I've seen many seniors who have tried many different things and then maybe mastered in one of the things. So there are multiple roles and it is easier to start learning as a beginner. Like you start with your basic BE branch only and you can go to any field, and later if you like it, if you do not like it, you can switch based on that. Again, like my domain is hardware backend domain, so that is physical design, that is placement and routing of chip, that requires timing, power analysis, area optimization, that kind of thing. So we literally place the blocks on the chip and then see what it is behaving like. And then there is this RTL domain also, where you write the Verilog codes, where there is this uh, verification team, formal verification, where you check for bugs in the codes, where you write test cases for the code. That is also in Verilog. And more, I think Ankit can tell.
Yeah. So, see, there are first you have to decide between two broad divisions, which is analog and digital.
Hmm.
You can't go with these two boats together. You'll fall. As early choice as you make, it's better. Probably in your later part of the BTech. Uh, I have little exposure of masters as well, right, along with jobs. So I can tell in that direction because masters happen with particular domains. Okay, you have to be very specific. Even sort of, you have to specify your job role as well. You can't take a digital design and let's say what maybe Sukriti works STA. You can't take these two in your MTech together. You'll not land a good internship. Leave that aside. So it will be a very long answer. Broadly,
Okay.
two analog and digital. Okay. As a BTech, still you keep little touch in that because they don't expect you to be perfect with one of them. Okay. So be okay with
Mhm.
both. What if at the end none of these digital companies come? And what if Texas Instruments only come with an analog role? They
Yeah.
don't want experts at a BTech level. Okay. So, but you should be good with this. Digital roles are more in the industry. Simple. Digital is easy to study, and digital has a flow. Digital has a flow that from spec you can go to RTL. Then it will be having verification. Then it will be having DFT, STA, synthesis. STA synthesis you can mix. STA is done at every level.
Hmm.
Synthesis, then there is something called GDS format, which you send to the fab. Then you have the fabrication. Then chips come out. Then you have the post silicon testing.
Yeah.
This is digital flow. Analog is a this digital is a very good flow, right? Anywhere you search, any company has this flow, and all these steps of this flow has is an engineer. RTL, RTL engineer. Verification engineer. DFT engineer like me. STA or synthesis, it's a one engineer, back-end engineer like Sukriti.
Yeah.
Then you have people on the fab. Okay, those might not be trained engineers. Like India is developing at 3 4 places fabs, right? You need people there as well. That is one more job domain which we neglect. That's also a VLSI domain. Okay.
Hmm.
Second division, big division is analog. Analog is complex and it doesn't have a very good flow. It's a custom flow. Like I have to design a SRAM. Example, SRAM, basic SRAM requires 6 transistors. If some people you would have studied or you might study. Now
Hmm.
those six, I am talking directly in terms of transistor. Means I have to place transistors. I have to open Virtuoso. I have to do DRC, LVS, those checks, right? It's a custom flow. I need to find the current capacitance. In digital, I will never talk about these terms. I will talk about 1, 0. I will talk about AND gate. In analog, you can't talk about AND gate. You have to draw that, make that AND gate. Okay, you need to know the current consumption. You need to know the capacitance. That's why these are the two divisions. Digital, sort of easy. Basic subjects like basics of electrical, basics of electronics are good for both, like must need for both. Devices, must
Hmm.
for both. Digital electronics, you need to be very good for digital roles. Similarly, there would be a subject called analog electronics and signals and systems.
Mhm.
That is for analog. On top of it,
Hmm.
for digital, you add Verilog as a code. For analog, you learn this DRC checks. I mean, Virtuoso. You would have it in your college 100%. So you need to do those. So you have to demarcate between two, and you can only go for one boat.
All right. I mean, I can't say that I understood all of that as a first year student with all these complex terms,
Yeah.
but definitely get the idea, and I feel like I'll get it as I move on. I'm actually in Phoenix myself. I'm a triple E student at
Okay.
BITS Pilani, so I'm hoping to get into the core electronics as well.
So yeah, in second
So,
year subjects are important, like he mentioned, digital design, this microelectronic circuits, microprocessors, ADVD. So these are subjects you anyways learn in your second and third year. So these are the ones which are basic important, and computer architecture. Additionally, that's like an Opel or a Dell for you.
yeah. Um, all right, perfect. So now I guess we move on to the college life at BITS Pilani and that strategy. How are we meant to escalate in the college life? So yeah. So my first question would be, what kind of college journey should an electronics student aim for in order to get into core industry? And here we will talk about projects, competition, research, or internship, and which one of these is the most important.
So I think it's very important to explore. It's very important to like start exploring from your second year Opels, because like in Opels you get a chance to study and like choose what you want to do. And
Mhm.
again, like some subjects are just to give you a flavor if you want to go into that, if you do not want to go into that. So that is a great thing which Opels should give you. So I think again, this computer architecture is a very nice course, because it gives you understanding of the system pipelining, then memory, some parts of it. It gives you a flavor. Then again, you have to decide if you want to go into it, if you want to study it, how much you want to study it. It gives you a little bit of Verilog as well. Then there is this neural networks course. This is also good. So again, all of these are different fields. You just need to see if any of it is like clicking with you, be it like
Okay.
OS OOPS direction, IT Dells, or be it in like Phoenix Dells, which are this Compark and Labs and maybe an NFL, some kind of that. Again, in projects are really important. So with your Dells, try to maintain like one or two Dells in your core electronics as well. Sometimes ADVD also has projects, so it's also good. But otherwise, also SOPs and LOPs, they give you a real understanding of how the systems work, and they give you understanding. Maybe in some projects you have done MATLAB, and something you have done LT Spice. So overall, you know different tools, and now you will have a good idea of what you want to do and if you are liking it or not. So it's really good to explore as many things as you can, because in second year especially, because that gives you an idea if you want to go into it or not, and that
Oh,
develops an interest for you.
okay. Ankit, would you like to add to that?
Yeah, so I think it's been time for me since I graduated. I might not be able to talk in the terms that Sukriti did. Okay, I'll talk in general then. First is like anything, let's say VLSI or anything. Best would be try early, succeed or fail early, like, and see your interest.
Yeah.
It's very good to confirm within second year that I'm not interested in VLSI. Far better than taking it to the fourth year. and then deciding ki I made a mistake. Jobs are tough in VLSI. I could have done coding, and within months, my friends got placed in the big companies. Okay, so you have to decide it early on by trying certain things like subjects, projects. Uh, be little early in your decisions and career. Like if people are planning for projects in third year or second year end, go and talk to a professor within, let's say, the first year end.
Yeah.
Let's say you don't get an internship in your summer, first year summer. Sit in your campus. I don't know I don't know if it is feasible or not. I don't know. But if there is some professor who allows summer projects, then try that. That is a quality work, far better than the industrial trainings that students go for. Okay, I mean, in government companies. Better than that, you can explore these real projects. Take up a small, take up a small project yourself. Do a Verilog of it. Try to mimic the same in an FPGA board. See if it interests you. As simple as a traffic light sensor. Do you like it when the FPGA board glows the light and you wrote a code and now you're seeing a light of that? That's a like software to hardware. Do you like that thing? If you like those, if you like that, okay, a circuit worked here, but something happened in real life. I like it. Then maybe this field is for you. Try to explore more. Uh, Subjects, maybe be little early on the subjects. You have every resource online. Need not be like this subject is my fifth semester. No, you take a class, study it in 6 of it. Move ahead if you like it. And
Okay.
focus, like before the internship time, you should be ready with your project. Don't be like when people, let's say you don't get an internship, then I will do a project. Start a project early on. That can be on your
Okay.
sole discretion. You can fail, you can try a project, you can try a project for 1 year and then see, oh, I don't like it at all. Or better that you will be very early in your, so try to be little early with your projects, with your subjects, with your decision, and then you will be little relaxed in maneuvering the college, because you should enjoy the other parts of college as well,
Yeah.
like your personal, this VLSI or coding is not the only thing. Okay, I made this mistake. I till my third year. Okay, I was only a full studious person. I was going through research papers, and then I realized that okay, no, I got internship. That I had 3 research papers within third year. Okay,
Oh.
Wow.
because all these summers I stayed in college with the professor, 2 3 friends, but doesn't make me that much happy. Okay, but I enjoyed my seventh semester a lot. I had a 6 month internship. I already had a job. I had an internship. I was into everything. I was into hospitality, bringing the guests in college, managing the event. Uh, that is something I cherish. But it's not to glorify. This is the only word. This I could cherish because I had a made cushion.
Yeah, true, true. You can cherish that because you had backup in your mind. That's true. But again, it is really important to have both. Like
Yeah,
CGPA does determine things, but CGPA is not everything. More than the letter grade, whatever you are getting, it's more important you understand the things. If you do not understand it, doesn't mean if you have an A on the subject. So the basics are the things which are more important. And again, I like to believe like what science is to 12th is like what physics is to engineering. You can go into whatever field you want to. It gives you a lot of things to explore. So you can try whatever you can go. Like I have seen my friends from electronics going in like literally different fields, and like we do not understand what we are talking about. So everyone is working into different fields with the same branch. So that, and not even in like hardware, they are in software, maybe they are in product, maybe they are in finance. So like it data science also. So many different fields.
All right, that sounds great. So, as you already said, engineering is very, very broad, and we need to explore everything in the first and second year, actually as early as possible, as Ankit said. So, my next question would be like, how do you like the rate the importance of projects, internships, competitions, and research? Like, how would you describe like which one is the most important, the least important?
there's no order.
Yeah.
Oh, there is no order.
I think projects and internships fall in the same category because if you invest your time that much and if you actually get something out of it, it is in the same order. Because more than what you get it on the resume, it's more about how you feel after doing that. Means like if you get a good outlook of it, if you want to continue doing that project, if you want to continue in that domain, or if you want to switch fields, like that kind of clarity, that is more important than what you actually did in the project.
And your from my what I feel is project should be like that, which has a scope of research.
Yeah.
So try to, if internship is one, if you get an internship, best go exit and do your best in internship. It's the best. It's learning on the job. Okay, there's nothing better than getting a corporate internship
Yeah.
proper. That learning compounds extremely well. Doesn't mean you can't balance it with college. Okay, again, I have like it's been 5 6 years since I completed my BTech. I have more examples. People who didn't get internship, many are doing far better. Okay, I mean, some got into Nvidia. They are financially independent. They didn't get a job 2 years later. Okay, went for something, did some MS, stayed in college for 6 months. When everyone is doing internship, they don't have anything, but they grinded.
Hmm.
They are in other parts of the world. Okay, some got into Nvidia, is financially independent before 30. Okay, so that's a different. You don't compare with others' journey. Number one. Now, regarding project should not be basic is okay. Since you take time for your project, you should make it till the end. Your project should be like from 0 to 100. It should be made from a simple. It should end at a complex note, and with that, you will be able to file a research paper. Now, what it helps you with, research paper is okay in conference, not necessarily in journals. What it helps you with is some students or some people don't want to go for a corporate job. You can show it as a research paper.
Yeah.
Sometimes research paper is not good for industries. They feel that you'll take an experience of 1 year and exit to do masters, MS.
Hmm.
There you can hide your research paper. Okay. So if you have 10, then only you can show 5 and hide 5, right? If you have 2, you cannot show 5. So have research paper, have a project, and play as according to the company. In my personal example, I had an internship from ST Microelectronics. That too, I got through online LinkedIn, reaching out to people. I had a job in a consultancy company, Big Four, PwC, because I
Okay.
just sat and the first company I got offer, and then I could not sit in these companies. Synopsis and all came late. I had some financial thing that okay, I need a job, and it worked out. My internship worked out. I got a full time. This is a separate story. Now, what I did in my first company, I was among the top 5 in my class. Okay, good CGPA wise. I had 3 research papers. Only 2 of us had in a batch of 120. Now I had to convince them that I'm not interested in electronics.
Hmm.
Why I want to go in PwC is that I have grades, but I don't like it. I just read it for it.
Hmm.
I hid all my research papers. I added my that okay, I'm into this club, that club. Okay, I'm into hospitality group. I'm into this event, and I study and I get marks. I'm not interested in electronics, and they were convinced. Okay, so you should have all the bits and plug and play. You should have 5 resumes as a fresher.
That's very valuable actually. That is what is required. Based on the company, based on the role, you should be having resume to apply. And again, it is based on your interest. Some people are more interested in research, so they should have more projects, more research projects. And some people are more interested in jobs, so they should try for internships and like reach out to people like on LinkedIn or something like that. So it really depends on person to person. You can't rank it. Some things work for someone, some same things might not work for someone else. So that case also happens. So maybe just like open your possibilities as much as you can.
All right. So that was actually meant to be my next question. So yeah, my next question is let's go into specifics of how to make a resume stand out to a semiconductor company, and what does the entire hiring process looks like in the core electronics roles.
Okay. So fine. It should be again mixture of your projects as a fresher courses. Okay.
Hmm.
So there is a journey. Okay. Every time you'll feel you are in the mid of the journey, like someone is into early career, like Sukriti. I'm sort of mid career, 6 7 years. Some are in a later career. Okay. You don't need resume after 13 14 years of experience. Okay.
Yeah.
Only your connections work. So, early career, okay, there is the main game of resume, okay,
Yeah.
and there you make a mistake of two things: either not writing what you have done, and second direction is writing too much. So there should be a balance. You should know the relevance of it. Lengthwise, also, I would tell people go like all extreme on resumes. 2 page resumes max. Try to fit it in 1 page. I have 6 years of experience. My resume is 1 page since last many years. Okay, and I'm able to fit in because you add the real terms. Don't brag about some line which can be done in a single word. Like I did this to increase this. You can write one word, right? Optimized it by 10%. Okay, so
Hmm.
resumes, projects, your role in the project, real outcome of the project. Okay,
Hmm.
so no one, see, they will always ask you, if you are interview, they will ask you what this project is about. No need to describe it. Project, one line outcome. If it's a group project, exactly your role in the project. Was there a paper coming out of the project? If there is a paper ongoing, you can write a filed a paper for this project is in a conference. Okay, that is again a good thing. You can write presented in a conference at this place in India. This is about projects, your obviously your curriculum, and depending on the job role, you can add the subjects as a fresher. If you're applying for, if Intel comes or if another semiconductor comes, you can add digital course or whatever the courses you can have. I think she can tell better. Let's say Texas Instrument comes for an analog role. You add the analog courses. You add the tools like Virtuoso, MATLAB, more. So again, it's a plug and play. But lengthwise, also I want to tell, I have seen very clumsy resumes. Okay, it should be, don't go for beautification, it's a very tech role, but go for good strict words as small as possible. Like it's very good if I get a mail and there is a 1 page in a resume, I double click, I don't have to scroll, it's a single page, I can watch it on my mobile. So recruiters are not some fancy people, right? They're normal office going people. If they are going back from office to home, they get something on your mobile and they can see it in a single page. It's good, right? So you have to think from that perspective, what will land you a job.
And also, like, again, subjects are important and like that. And the recruiters, they know, they have seen so many resumes, so they can pick out what is real and what is not. So do not try to fake too many things, because that is like easily visible. And they do not expect as freshers you will have very big projects, because in college you can't do that much. But whatever you do, you should be like very much honest with it, and like again explain it. Again, any recruiter does ask, like in all of my interviews, everyone has asked, what is this project about and what did you do in it? So then you should be able to explain, because that is where people get caught, if they have written something like that. So be clear what you have written. Like, just do not write some copy paste something. Be clear with what you have also written. And again, like, try to maintain it in one line and like short and concise. Again, the college does stand out in it, the CGPA does stand out in it. That's the first thing anyone would see. But after that, your CADs, your subjects, and then your projects and internships would come. Internship would again be at a higher priority than projects. So every name matters. Every name matters on it.
All right. So keep it concise. Basically,
Yeah.
that's the main advice that I saw. And
To the
yeah,
point, not just concise, to the point. I mean,
okay, yeah, to the point also. So okay, so so what is the okay, 1 second. Okay, so now let's move on to what's more important. So as you said, it is a very broad field. So what should be the goal of a college student at the end of the year, and at the like end of the college time? What should their goal be? Being a generalist or a specialist in some field, or just have the common knowledge? And what separates an average engineer from a specialist in an engineer in a specific field?
I think for college, you should be having a general outlook, because as you enter the field, you can choose your specialization, you can shift your specialization, but you should be open to everything. If you limit your opportunities from the start, that would be problematic for you as well, as because as freshers we do not know what actually that role is. Reading the job descriptions before entering industry, we do not understand it that much. So I think be open and like be general will benefit more, because you can switch fields when you enter the industry also, after you enter also.
Yeah, you should be like a very flexible mold. Okay, whatever is given to you later or whatever you enter into, there you are able to be, because these roles you cannot be a specialist in BTech. Simple as that.
Yeah.
You don't have that much tools. You don't have the real project.
Hmm.
These online projects in VLSI is not the standard. It's not like coding. Again, I don't have any grudge towards coding, but it's not as coding, okay, or as easy resourceful as coding. You someone who is not in a good college won't even be able to use the tools. You can only study the courses, because these tools are the barrier for VLSI. It's not, again, plus you don't know who is doing what. Like in coding, you have a central common field. You can do some code chef. You know, even India level, what are the codes going on.
Hmm.
Here you don't know. Here your next college might be very good in research, VLSI research, or your next college might not be knowing VLSI at all.
And then research to industry gap is also there, because everything at research is not directly proportional to what's happening in industry.
Correct.
And again, experience matters here more. So in college, people do not expect you to be having some like hard coded knowledge of something, because they know it is not, some fresher is not experienced. So people have that understanding. I think experience matters more, and in general you can change your field after entering the industry also.
Yes.
All right, that's insightful. Now, I would like to ask you a personal question. Can you share a major failure or setback in your career, and what it taught you?
Ankit, you should go first.
Uh, like failure on the work, or failure in terms of what I had thought, that kind of like the job I got, or so there have been phases. Maybe a small one I can tell. Uh, not bragging, but I was among the top 4 or 5 people, like whom people knew they will go into VLSI. Okay, among a batch of 120. If you have 2 3 research papers as a BTech, okay. Now, due to some financial thing, whatever, I had to take up a job. I had to keep a backup, and I took a
Okay.
job. I sat and I got the job, luckily or unluckily, on within the first company I sat. It was a consultancy company. Then these companies came: Synopsys, NXP. I was sitting in college, good GPA, everything good, research papers under me, all professors knowing me. I was not able to apply. Companies are coming. People who have come to study from me, like you tell me the basic questions, they getting selected in these companies. I am sitting and having a job in this consultancy company. But yeah, it was a sort of bad phase. Plus, as a student, right, today I am way mature that to understand that neither VLSI is the world, neither this coding is a, this is just a part of my life. This job.
Yeah.
That time it was like, okay, I put 3 years. I used to like go to the professors in second year when these classmates didn't even know VLSI. and now I with full I cannot sit. But yeah, then that's why I am very active on LinkedIn there, because LinkedIn helped me. I got an internship. Then by the end of internship, I had two, three job offers from VLSI. Like in in my internship, I used those people connect. I mean, I used the connections. I used LinkedIn more. I used that I had come from a small place to Noida. I used to go to this company to give interviews, send every week. Even though when I got a full time, I kept on exploring. I was ready to move to Bangalore that time. So maybe never stopping till I had properly entered VLSI.
I think
Wow, that's
I
very inspiring.
yeah, very inspiring. I
Yeah.
also have like similar thing to say because Intel came very early and I got an interview for the internship. So I qualified for internship, but if you have internship, you can't sit for first sem placements, and most of the electronics VLSI companies come in the first sem. So I could not sit for any of those. And again, I did not know if I had some offer or not. And again, you can just apply to some dream job roles and things like that. So later it worked out really in my favor, but during the internship that time I was not having much experience with the work itself because it was just the starting. So I was having small work to do, so I did not feel like I'm doing much, and I could not even apply to other companies because of this barrier. So that is a phase that comes in every person's life, like Ankit said, and like this is some in between of internship and job kind of phase. So till the time you get a job, you are very terrified as a student, and it happens with everyone. So like this happened with most of my other friends also. So what you do is you keep on applying to other things which you can outside college also, check through LinkedIn, go for off campus placements, and talk to multiple people. That's how you can like go out of it. Later I got a job from my internship only, so that helped me. But yeah, this kind of thing can happen.
All right. That was actually very like very good to hear. कि मतलब you can still
Yeah.
revert back uh, from wherever you are in like in whatever position that you are, and you should maybe like what would you suggest? Should you take your time to sit for internships, or did you do the right thing, sitting for an early interviews and then not being able to like? Would you keep your options open if you had to do it all over again, or would you just
Uh,
have a secure placement?
Um, See, now I am financially way better than I was 6 years back. Okay. uh, Now I will be very biased to say that okay, follow this, follow that. Again, I didn't have a big financial issue, somewhat like it's just that I didn't want to depend on my parents,
Yeah.
or I don't want to break and go for masters. Plus, I didn't want to go for abroad as well.
Hmm.
I want to be in India, like it's my and I want to work in more companies. Now, though I have done whatever I wanted to, I had a dream to work in two companies, Qualcomm and Intel, and within 4.5 years of my job, I did both.
Yeah.
Now, whatever comes is a luxury to me. Okay, I'm happy. I cherish it. I don't cry that this job is bad, that job is bad. Okay, this was my dream 6 years back. Will I get a chance to work in Intel and Qualcomm? I love these two as a company. Intel is the first company which I loved, for which I wanted to come into VLSI. Then ST Microelectronics, I didn't know it came as a bonus. Amazing company. So I would enjoy more of the college life. That I want to change. Not this. Career wise, I think I was well sorted. I had planned my exit routes very well. If I would have been a consultancy, I would have been a very good consultant as well. I would have been doing an MBA after that, leave this VLSI, exit, a new journey, make more money, maybe, or what I don't know.
I think that is the thing. Like what you do later, you realize ki how did it help you and how you grow from it. So like it is fine. I think if you are very clear from the starting you want to go into electronics, it is not bad if you start from your early interviews and you get first internship that comes to campus, because if you want to go into it, it is good to go as soon as possible. Again, if you will get an offer from it, if something would happen that really changes every year, that really changes every team, that is something which is actually a luck dependent thing. Because all of my friends, we came to the office and we have the same degree, but now in internship all of our teams are different and we are working with different things and we are working with different managers and we are working on very different thing. Like at the end of the year we could not explain like what we are actually doing to each other. Like it is so different of a domain, but we came from the same degree. So it is not so different at the, and again how the job offers came out, it was all, everyone has a different journey, you can't compare. And it is really changing every year, every team, every manager. Sometimes some teams, well, there are a lot of things happening in the industry, it is fast ever like evolutionary, like changing and things. So if you're clear you want to get into it, you should go for early internships, it's a good thing only. But again, you need to be prepared if for off campus placements also, you need to be prepared to like reach out to multiple people or talking in your own like office also to, so sometimes talking to different managers also help, they might give you some position. So things like that you should.
I yeah,
Yeah.
I know a story. Someone getting a job because he shared a cab with a manager from Nvidia 6 years back. One of my seniors, he had an internship in Infineon. He didn't get a full time. One of the last months of his job, he was sharing a carpool in Bangalore, and that was a manager from Nvidia. This is not a story because today Nvidia stocks are up. We know it from like 3 years back.
Yeah.
Nvidia was okay that time, and he is in Nvidia from 7 years. Okay,
Oh.
now you can just see what a right place, right
Yeah,
time,
right
Bangalore.
place, right time.
Yeah, my immediate
And like reaching out to people, like talk more,
yeah.
very important.
So it's heavily luck dependent. Okay, heavily luck dependent. You be prepared with everything you have. As a student, you have all the cards that they want analog, you can put analog, digital. Apart from this, have a plan B and have an exit plan. You're not married to VLSI. Okay, have an exit plan. Fine, if it doesn't go well, am I like as interested that I need in VLSI? I didn't get through this. I need to go for MS. I need to go for masters. I know people like that who
Yeah,
were
change
so
plan.
interested that they couldn't take a job. They didn't get a job after bachelor's. They were so sure that I want to work in VLSI only. I will go for masters if I didn't get a job. That's if you're okay, then have a plan B. Not VLSI, fine. It's hardly you're 22, 23, 24.
Yeah.
Next job you can do amazing in a second job. Sundar Pichai, metallurgical engineer. Take examples from big people. Okay, that not big people, like you'll see it every day. I mean,
Every day, yeah. So one of my friends, he had internship in Texas Instruments, but he did not get an offer over there. So the second internship he did was in data science, and now he's currently working in data science. So people completely shift their fields. And one day he was telling me something about transformers, and I related to electronics transformers, and he was talking about data science transformers. So things like that happen.
yeah, it's luck dependent. One more short example is just now some our Intel CFO. One video was released with you, okay, in our portal.
Okay.
Now he was about to go for music. He was about to enroll for music when his father told no and got him enrolled in this finance.
Oh,
He is the CFO for Intel from last 6 7 years, Chief
oh,
Financial Officer.
Oh,
yeah.
Okay, and his
wow.
interest was music. Just at the end, his father. It's a video like just 2 days back. That's why I saw in our. There is a portal for us
Yeah.
where the big people, they release some of their life bits. Read a lot, I think.
Oh, wow.
Yeah, yeah.
Read apart from your college, right?
Read, be updated with technical news, be updated with what's new, what's coming. So, like, you might find some interest and then you will find ways to learn it. Like, if you find it interesting, you will find ways how to study for it.
All right. Thank you both for You're sharing your valuable perspectives and very interesting stories. Your insights were definitely very, very valuable. And I personally had a lot of fun speaking to both of you and taking your advice and experiences in. So let's move on to the end of the session and let's see if the anybody in the audience have a question and have the final Q&A session. All right.
So,
Somebody has a
we'll
question.
be wrapping up by 3:15. Is it okay? Or
Yeah, yeah, sure. We'll be wrapping up by 3:15 for sure.
okay, okay, okay.
Okay, so Madhav Jindal asked a question. In advanced nodes like 5 nm to 3 nm, what are the most challenging trade-offs you face between test coverage, power-aware ATPG constraints, and pattern count, and how much of that is becoming a physical design co-optimization problem rather than pure DFT logic insertion? Also, in real projects, what usually becomes harder to close at advanced nodes, setup or hold? And how does that influence placement and clock tree strategy from the beginning?
It's like a 10 question actually.
Yeah,
Yeah.
Mother with many questions. Like the question seems like, is there any course or what you are doing in this like VLSI flow or something? Because there are many things combined in one. It's not a one question actually. One line I can tell. Remaining, if you want, we can share our. I can share also my mail ID. If it's a genuine question wise, you can mail me or you can. I'll tell you. But see, we are one of the centers of the full VLSI flow. Okay, it's not that I am working on silicon. She is working on silicon. We are one of the fillers. We are not the architects. Okay, we cannot tell you also silicon. DFT gives patterns to silicon. Now, just a single answer. As we shrink the nodes, we don't know. We don't know what can come up. Okay, because your transistors are coming closer and closer. The wires are coming closer. Uh, Currents come into play. It's not now a purely digital thing. It's capacitance, it's inductance, it's current. Now it has gone beyond the VLSI. It's gone to
Yeah.
physics.
Yeah.
So it depends what is your constraint, how complex is it. Mostly, the setup and hold is the main thing. Okay, uh, because setup can be fixed with clock frequency reduction and all. But this question is way too big. There are
Yeah.
6 7 questions in that. Advanced node, no one knows. Okay. Yeah, I think Sukriti, if you want to add, or in next questions also you can see.
Yeah, I think that only like with changing technology because we are still working on it. So there are a lot of things which are in progress right now. We also don't know how it will be getting resolved. But yeah, there are setup violations and hold. Firstly, we try to converge to setup, and that's what is called convergence. So again, crosstalk and like physics issues, like you said. So that's a lot of things coming in.
Right. Can take the next one. I think 4 5 are there. Quickly we can answer. Sukriti.
Yeah.
Okay, this is a much more simpler question. Is coding more important than core electronics concepts for semiconductor
No,
roles?
no. Next.
Core electronics concepts are more important, and coding you can add on to it. Like you can have a little bit of that.
All right. So the next question: what kind of college journey should an electronics student aim for to be industry ready?
I think we covered it.
Yeah, I think we covered it.
We covered it at length.
Try to
Yeah.
explore as much as you can.
Okay. How do you come up with a research paper?
Read a lot of them first.
Yeah, I think you should like go to some professor which you know who is in your field, search for their domain, search for their research, and then see if what you are interested in. Go to them, talk to them, and ask you want to start a project. Start with a project first. Start some SOP or some log, and then with that you try. I want to write a paper. You like convey it to them, and they will help you out. Professors do help you out in that. So first study their research domain and see what interests you.
Correct.
Okay, he asked a follow-up question. Can you suggest any sources to read?
IEEE.
I think, yeah, that
IEEE.
Google Scholar, go to that. There are like journals over there. You can find
You
many
have
like
IEEE Explore access.
IEEE. Like if
So
you go on Google Scholar and you type a particular subject, you will find multiple links for that. And with your BITS email ID, it's accessible also. So yeah,
if not, there is a maybe I don't know. There is a hacked website. If you don't have access, you can get all the papers. You just type the link. Maybe I'll share with someone's mail ID later.
yeah, but again, library resources give you that.
So
So
then,
go find like search topic, find some research topic you want to study about, and then if you search it, you will find multiple papers. This takes us some amount of time in like
yeah,
first,
months.
yeah, but like you will be able to do that. And once you start finding it, you will find linked papers also. You can read from their references. You can go to reference and then go to another paper like that.
True, true.
So it will be easy once you start doing it continuously.
Yeah, so IEEE and Google Explore. In IEEE, the level is go for journal paper, then the conference paper.
Yeah.
Filter it. You can filter by removing the journal conference paper. Conference paper are sort of local. So your aim initially should be to write a conference paper, but don't read a conference paper.
Yeah,
Journal paper are like the benchmarks.
correct.
Very tough. Even one journal paper can make your 7 8 months if you try to replicate it.
Replicate it. Yeah.
It's worth it. Worth
Yeah.
it. You will learn 10 subjects if it's a worth journal paper.
Yeah.
So you are not qualified enough to judge. As she said, go to a guide. They will give you a paper.
Hmm.
They know which research paper. You can take a journal paper, can be very substandard or can be very complex. Go to a guide, tell them I want to learn and I want to. They will give you one paper. Like even master's thesis completes within 1 2 papers if it's a quality paper because it checks from one subject to like 6 7 subjects can cover in one paper. You'll have to learn everything. Okay.
Yeah, it will have some coding, some MATLAB, some SAS, something like everything will be mixed in it. So, like to read with it, you should firstly approach a professor.
Yeah.
Okay, so now we have another question by a fourth year student sitting for PS2. He prefers an analog role. He has done 2 3 projects, one intern, decent technicals, and he's asking for some tips for the interview.
I think be prepared with if you have done mostly things, so it's good. So be prepared with what's written on your resume. You should know your projects, and then computer architecture, basic digital electronics, digital design, that kind of thing, and basic flip flops, basic NAND gates, gate level questions, that kind of
And I think this
things like
is
that.
analog also, so you have to add
Yeah,
those bits like devices, device physics.
Yeah,
Uh, Again, I am not aware if you have a subject called signals and systems.
yeah, there is,
There
there
is.
is.
Okay, so that is the sort of base for analog. If you can go to the level of ADC and DAC,
Hmm.
that only for analog roles. Otherwise, what she told, that is there. Even for analog roles, as a fresher, they can ask you from digital. Okay. But
And mostly people may ask one, two like puzzle kind of questions also. Simple Verilog coding also. Simple Python programming coding also. Like some loop, something like that. Binary sort search. Like simple things which we do as like maybe first year students and 12th grade students. That kind of thing.
all right. I think that is it for the Q&A, and that wraps up our beautiful session. So I would like to thank our speakers for making time to helping our students and helping students of the next generation and giving us their time. And yeah, that's it.
great, thanks.
All right.
Thank you.
Thank
Thank you
you.
so much.
All the
Thank you
best to
so much.
everyone.
Okay.
Yeah. Thank you.